So yesterday there were sessions on geothermal and carbon capture. This morning, we will do energy, fluids, and minerals, which also includes oil and gas, and this afternoon, energy systems and efficiency. Now, so far as the, yes, I shall use this one. Energy, fluids, and minerals is concerned, we have focused, post the COVID, we have focused on 4 different areas: deep water, shale, gas, hydrocarbon, helium, hydrogen, as well as critical minerals. So those are the areas that you will be hearing. This is the program. I think you already have a copy of that, and the session will end with a panel discussion. We have a very distinguished team of experts. So that will be the finale of the session, I would say. So EGI has a corporate associate program. You see the package of benefits that is offered as part of the membership. Those are also listed on that banner, so I'm not going to repeat that. But a key component of the package of benefits is the EGI Connect, which is our basically archive of all what we have done over the past 50 years. Christopher Kessler, he is in charge of the EGI Connect, so he's going to give you a demo of EGI Connect, what it is and how it works. Chris.
Good morning, my name's Christopher. I'm gonna run through some example workflows with EGI Connect. So from our website, egi.utah.edu, under products is your link to EGI Connect. So EGI Connect is open to anyone to review the catalog, but the actual data behind it is reserved for our corporate associate members. So we only will fulfill requests for data from current CA members, and anyone else who requests would be politely declined. So EGI Connect is a kind of a front end portal or a platform that allows you to browse what's in our EGI library catalog. The details of what EGI Connect contains are here on our website. To launch EGI Connect, there's a button here that'll take you straight to the map. So EGI Connect is largely map-based. It does have tabular data behind it, the attributes. That's standard GIS 101, is you have features on a map tied to information and metadata behind them. The available layers in EGI Connect are shown here in the layer list widget. So EGI reports library, those are reports that EGI has completed over the long history. There are a few, I think just under 100 or so, that are considered thematic, so we can't necessarily show those on a map. However, they are available in tabular form for you to review. But we can't necessarily show those on a map because they're topical and they could apply to almost anywhere in the world. We also have non-EGI technical reports. So these are reports that are in our catalog, but they're not necessarily completed in-house by EGI staff. Their staff may have contributed to some of these reports, but these are just other reports in our repository. Same goes with this layer here. It is reports that still need to be geolocated if possible, but they may end up being thematic as well. We have a significant maps library. And we're working on correcting locations and adding new ones in as we go. We have just under 400 or so theses and dissertations scattered across the world that are available from our library. So these next layers are fairly new. We've had them for a few years, but we've separated out our chronostratigraphy reports and kind of consolidated them into the wells that have been analyzed and studied under our chronostratigraphy group. Same goes with the chronostratigraphy cross sections. Those are wheelers or vast chronostratigraphy cross sections that are related to these wells. We do show a catalog of our geochemistry, organic geochemistry available data. That's a pretty big database. You know, it's concentrated in certain parts of the world where EGI has worked over the years. But it's just a catalog. Anyone can look at it and it'll tell you specifics of the kind of data we have, so on a sample by sample basis. We do have images of well logs and seismic data available. And for some of those well logs and images have been processed to LAS and SegWi files, and those are available to our CA members and on request. I'm going to use the start. Guyana Basin is kind of my base of operations for this next part. If you're just coming in or you're new to EGI and just want to browse around, this info button here on the side is a really good one to use. So it will adjust based on your map extent. So if I zoom in, those numbers will change. If I zoom out or move, those numbers will update as you go. And you can browse the titles, the reports as you move around the map. If you click on one, it'll show you where it is on the map. So that's a good one for just if you're just casually browsing around to see what EGI's got going on. I'm going to go ahead and close the layer list. These are all, you can close any of these widgets and move them around to get them out of your way as you work. It is possible to create your own selection. If you prefer working with that, you have a choice to select by any of these selection methods. Rectangles like the default, most common one. So I can just come in and make a selection. See, I got all this data here. The information, the summary will highlight what it found. Any one of these you can export right now to a table for use offline. You could create a GIS layer for use offline in your own system. You can view those selections and the attributes. And it'll say it's 11 features. So any one of these, you can go ahead and do the same. You can open up, export, and get any statistics on them. There's just basic summary statistics if there are those kind of columns in the data. So perhaps maybe I'm browsing around, I'm looking at the Guyana Basin, and I want to add some data in here. I see EGI's data, but maybe it would be helpful to see my own data in relationship to what EGI's got. So there's an Add Data button. You can add anything from ArcGIS Online, anything that's open to the world, or if you have resources that you can access ArcGIS Online from your organization. Yeah, if you log into that, you could add it here. It's only in session. We never see it, so there's no security problem there. If you have your own ArcGIS server or have access to one, you can enter that URL here and add that data on top of ours. For my demonstration here, I'm going to go ahead and add some data, kind of old school shapefile method. So I want to add in my area of interest happens to be here for my, go back. So I can see that's my area of interest. I can see what EGI has going on there. I can also add in, I'm going to add in my well data, see how that relates to EGI's data. Very good. And maybe I'll add in my seismic as well. See how that overlaps with what EGI has. So there's some good overlap I can see with my data. And I can see based on the legend in the EGI reports, EGI's got a fairly new in progress report right there. That might be of interest to me. Anything I can add anything from ArcGIS Online. I'll demonstrate that. I have access to a feature service that I want to add in here just to provide some context of basins, perhaps. So I got this sedimentary basin scheme I'm aware of, so I can see. So it's adding in 2 different layers. Okay, so I can see that. So I've got the CGD Robertson sedimentary basins of the world. That's what I'm after. I don't necessarily need the basins from the petroleum provinces from USGS. So I can see how the basin relates to my data, EGI data, etc. So recently, EGI has been working on updating our library to make it a little more friendly for searching. If you prefer like keyword search, we have been implementing that. It is in progress, so it is not complete, but it has. Thus far, we've been adding location keywords and thematic keywords to our library in order to make them a little more identifiable from a keyword perspective, if that's how you prefer to work. So I'm going to use an area that I know that's done because I did it. So we'll go ahead and do Northern Africa. And perhaps I'm really interested in what's going on, or understanding stratigraphy of Northern Africa. So from that standpoint, I can go ahead and add in another keyword. So these keywords work together. Hit go ahead and apply. It's going to zoom in to that region, and it's going to highlight those reports that do have a significant stratigraphy component to them. You can browse the results here. You can also, same as before, you can export right now this information to a table. You could create your own GIS file that would just be these results. You can also view them in a table if you prefer to see the table now. You can even change the color of the symbol if you don't like it. Another widget we added to save some time. Oh, and by the way, after I did that keyword search, you get a layer here in the layer list in session temporarily. So another widget we've added is kind of a summary tool. It does have a keyword component. So these keywords aren't keywords that EGI has put in. They are referencing more physiographic countries, regions. This one does use the sedimentary basins layer I just added. So I could go ahead and put in, say, so it's going to come up with options. So the bold areas are the categories. So say I want to see the Guyana Basin. Okay, so it's going to take me over there. It'll add that outline of the Guyana Basin for me if I wanted to work that way. I can apply a buffer to this if I wanted to capture more data outside the Guyana Basin, just for good measure. You also have the option of drawing your own area of interest. So if you just wanted to draw an area like that, you can go ahead and work that way. What I'm going to do is I'm going to add in my same area of interest into memory here. So it's going to load that in for me. And to capture a little more data, the more regional perspective, I'm going to give it a 250 kilometer buffer. Okay, so that's going to capture a lot of data. So what this widget does is this goes into the EGI library and summarizes pretty much everything we've got within the area of interest I've specified. So if I go ahead and hit the report button, it's going to give me a summary of what it found. quick summary of what it returned. So at this point, what I can do is I could export all the tables for these results right now. It'll just, for each of these that had a return, it will give you a table for viewing offline. And then there's a print button here, which will actually go through and give you a decent summary. So a summary report. So it gives you the summary at the top, and below that, it will give you, the specific details of what was returned across all of our data in the EGI library. So there's chronostrat wells, cross sections. So some of the tables are a little bit longer to fit on like an 8.5, 11 page. So the tables will wrap around. So here's the geochemistry. This is still geochemistry. Tells you TOC pyrolysis, kind of data we have for these locations, etc. So the status bar at the top was running when we left. What that was doing is creating a map. So you have a base to tie the tabular data to what you see on the map. You can change the title of this. You could add your own comments in before you print for viewing offline. This is the kind of report you could send to EGI if you had a large request of data. We could send that back to us and say, hey, I want this data in this region. So for CAs, anybody can view the project summaries for anything that we show. So these are just PDFs to give you a summary of the report in question. It is also possible for a CA to make a request that takes them to a form on our website. They just have to put in their name, email, and any message they feel necessary. That comes directly to us, and we fulfill the request, uploading this report to them via secure file transfer. It is possible to completely bypass EGI Connect from our web application. If you prefer, if you're using a GIS package like ArcGIS Pro, you actually can come to EGI here. So if I just type in EGI Connect, so that'll take me directly there. And notice I'm not logged in. So I can go ahead and add in features on my end at the client side directly. So I just added in EGI reports to my map in my office, wherever I happen to be. And you can interact with those features just as the same as you would anything else. It'll give you the details. You have the same links, the summary, and the request link. Same goes for any other GIS package that can support REST endpoint technology. I'm here in Quantum GIS, so that's one of probably the biggest open source GIS package, and it is free. If I wanted to add in EGI reports to my project, I can go ahead and do that and work with them on the client, on the desktop side via this connection. Okay, thank you. Any questions? Super. I'm always available. I'm on the website EGI, my contact info. So especially CAs, if you have any. Yeah.
Can I just ask a question? How much activity do you have from?
It has significantly declined. However, historically, we've had pretty high volume. Yeah. But right now, the volume is pretty low. Yeah. And that's been since, pandemic, things have really took a hit activity-wise. So our goal now, I think, is just to make sure that everybody knows we're here. We're still here. Yes. Yes, exactly. Yes.
Any other question? Okay, thank you. So
Thanks.
So EGI Connect is part of the CA program's benefits package, $55K a year. Now, the next presentation we are going to have is iCores Offshore. This is a database, offshore database for oil and gas wells, which EGI has been working for over 12 years or so. So we have regenerated it, and there's a new version. It's on Google Drive. So Tom Cook, he's going to show you how it works. Let's see that. Okay. So this is $40K a year, but for the CAs that you get 50% discount, so $20K a year.
Okay,
Okay.
great. Well, thank you for coming to EGI this week. Appreciate seeing all of you. So Rasul had a vision, and it was, can we take all the geochemistry information that we have from various sources, DSTP, ODP, IODP, for instance, as well as industrial and any websites, and can we just put it all in one place for the convenience of the users? And so iCores is an exploration of that. And it turns out you can put all the data in one place, but you also have the problem of trying to get that data back after you have it. And so you kind of have a double challenge. You want to keep making it bigger, but it can't be inaccessible at the same time. So we'll show you what our particular solution is today, and any feedback you can give us will be very much appreciated. I'll give you a quick overview of a quick query, although I guess I should talk about it. These are the things you can search for: area of interest that you want to go to, basins, the water depth, etc. Perhaps you want to focus in on particular pyrolysis values. I'm just interested in S1 from 1 to 5, for instance. Perhaps you're just interested in the stratigraphy. I just want to be looking for the Cretaceous period, for instance. We're trying to figure out all the different things that you'd want to be looking for. So those are our search parameters. You'll add up as many filters as you want over here, and I'll give you a demonstration in a bit. And then the data that get returns, we have over 400 different fields about geochemistry that are available. Here's what we know about the well, the depth of the sample, for instance, what we know about bulk density. Here's what we know by porosity. So it's a very rich database. Over here, it'll tell you where it is in the world, and over here, it'll give you the summary of the data returned. So let's just go ahead and say, I am looking for, in the area of interest that I have, over on this map, Gippsland, which is in southeastern Australia. And I'll just go ahead and draw a box around that. Label it. And that's my first filter. Now, the second thing I'm interested in that area, how about just the Cretaceous period rocks? Oops, not a formation. And then third, I'm looking for when the total organic carbon has a unit greater than 1. And as far as the data that will come back, we'll see the sample depth, its labels, and the periods and the TOC will all be returned. So I'll go ahead and say, well, how big is that going to be? Because sometimes you can get millions of records back, and that's not really something you want. But it tells you right now, you're going to get 6 columns back. There's going to be 1,200 rows, and that'll give you, 7,500 cells at most. Some of them will be blank because we don't necessarily have the data for everything. We do limit you at 10,000 rows here, just so it doesn't get ridiculous. Oh, and it can get ridiculous. We have about 11 million samples now, and with the work we're doing this year, we should be able to get up to about 14 million. So it's going to be a very rich set of data. All right, so what came back? We have report now on 64 wells with over 1,264 samples, and 2,500 measurements were in that level. So that's really nice. And if we want to, we can go ahead and just immediately download that as a spreadsheet. And there you go. So very conveniently, you can move that into your processes, since a lot of people are much more familiar with using Excel in their workflows. So that's just the first simple thing. Any questions now? I'll move on to a slightly more complicated example. All good? Okay. Yes. Mm-hmm. Mm-hmm. Mm. That's a great question. So I'm going to select one of these rows, and I'm going to say, hey, can you tell me everything about that well that you know? And this pops up. And it's going to say, this is the well, this is the depth of the well. You'll notice it goes down to about 2,200. And right here are all of the samples that we have on it. Now, I think what you've asked for is something we're going to add fairly soon, which would be one more tab where we say, show me porosity. And it'll look through every single one of those samples and make a depth versus porosity graph for you. So now, yes, you do know about that well and its porosity. The data is here. We just need to make that particular visualization, which is on the docket for this year. Great question. Okay. So you want to be here? Porosity, of course, and we pride ourselves on having the data source. What's the next one? Oh, sure, yeah. So basic well stuff, which you can find in a lot of databases. But you'll notice on the bulk density, and we have a lot of bulk density. Pressure types, the temperature, air, mud lines of the downhole. But here's where we really get into the rich stuff. Gas analysis data sets. Grain composition, percent sand, percent silt, percent clay, grain density. I'll just run through these kind of quickly. P wave is quite rich as far as number of fields available. And then pyrolysis is really, really rich. And we have a lot of data on that. Oh, sonic velocity as well. Does that roughly answer your question? Thank you. Okay, I'll do the second query, which is a little bit more in depth if we have time. So I'm just going to clear this out and start over. And in this case, I'm going to search on a basin and just the Anderson Basin. So here I don't have to draw a circle around my area of interest. So filtering on Anderson. And as far as what comes back, I'm going to control that. So I'm interested in S1, S2, S3, Tmax, hydrogen index, and the oxygen index. Fantastic. Then you can see right there, 11 columns are going to come back. And then I push this. And again, it's like, well, how much data do I think is going to come back? 11 columns, 556 rows. Very nice, healthy search. These usually take about 5 seconds to run. And we automatically zoom in on the area of interest, which you'll notice is in Yukon Territory, Northwest Territories. We've got 11 wells came back, 457 samples with over 2,300 measurements. So that's quite nice. I think I already showed you information about a well, but let's just do it again. What do we know about this well? And specifically just the sample that I just clicked on. So it'll take you straight down to where it is at 3433. And again, at a glance, we can see everything as far as samples about this well. And it's now scanning the database to see everything it knows about that particular sample. And so we have a rich set of pyrolysis data and a rich set of TOC data available for just that one sample. And I like your idea that we should just show the entire well on anything of depth versus a particular sample. Also like to point out, we try to keep the provenance of all the data. We want to know exactly where the data came from. So if there's any problems, we can go back and fix it. And so we show we got it from this website. Okay, as far as all the data, there's a heck of a lot of it. What can we do to help you scan through it? Well, how many wells have we got? There's 151 samples for this well. There's 88 for the next, 58 for the next. So we make that easy for you. What are the depths of the different samples? I'll just click on that by itself and say, here we go. Here's a histogram. There's 115 between 0 and 40, 87 between 400 and 800, etc. And then let's also look at a cross plot. Let's look at, say, the temperature maximum versus depth. What should be on the x-axis? I'm going to get this backwards. And there you go. Now, if you kind of look through this data, there's an interesting relationship with the Stony I-50, although it's a bit cluttered down. I don't have time to go through it, but there is a pattern there if you look for it. Okay, moving on. The pyrolysis TOC VR report, though, I think is the thing we're the most proud of. I'm going to select every single one of the rows and then pop this guy up. And he's going to give me an overview of how much oil might be in the area that I just selected, and it's going to do it sample by sample. So notice we can say, here's all the wells, and there's a lot of data, but if I want to shut everything off and then just turn them on one at a time to check them out, I can do that. And I've also got not just a histogram, but a histogram that allows me to hide things and show them specifically to say, I'm very interested in just samples between 3,800 and I'll isolate those for you. And we can color by many things, hydrogen index, oxygen index, whatever your area of interest is, that's the coloration that can be done on the samples. And of course, here you can see all the wells and all the depths of all the samples at just a glance. I'm going to go through these other ones kind of quickly, but one at a time. On the production index, you'll see that right here, it says this is the area that we're expecting oil. This is the area expecting more gas, and this is where the immature. So we can say, wow, that is a really good area. Which well is that? That well is the Tenlin A73. This sample's at 204 depth. And so now I have something to go and look at in more detail. Next one is very similar. We have an area for what's oil prone and what is gas prone. The next one as well, oil prone area, gas prone area. We can continue to look through the samples and see what's promising. Hydrogen index versus Tmax, once again. A lot of data kind of outside of the area sometimes. So it's like, this is the area of interest, but then here's a bunch of stray samples. Hydrogen index versus TOC. Once again, there is oil areas. Vitrinite reflections versus depth. We tend to have a little less vitrinite reflectance, but here we do see there is an oil area of interest. Again, just click on it and you can see which well and at what depth we're talking about. And then finally, the TOC versus the vitrinite reflectance, oil area and dry gas. So just a lot of analysis tools to help you look for your area of interest. So that's, go ahead. I'm sorry. Oh, I'm almost done. So that's just the geochemistry. Let's just look at some of the maps that we built in for your convenience. So for one, the seismic lines are of course quite important. And we have, I think, about 1,500 seismic lines available, especially offshore. And if you wish to download the graph on any of them, boom, this will, did I hit that? Oh yeah, there we go. This will give you the seismic line so you can see it. Is this a brand new machine or something? There we go. Okay. So yeah, like I said, I think we have about 1,500 or 15,000. Chris, do you remember? Yeah, no, it's a very high number, and we're looking to gather more of those. Another observation or another map that's available would be, say, the I think these are more seismic lines, just of a different type. And then finally, things such as the ocean floor age. I'll get that last. And you can see the floor age very conveniently. And then finally, the heat flow, which is, I think this is Chris's work, right? On the heat flow? Correct. So anyway, that is a quick run through of I-cords and really trying to go through Rasul's dream of, can you put all the information in one place? And then can you get that information back in a meaningful way? Plus, we'd also like to help you analyze that information. But most importantly, you can download it and analyze it yourself, because that's what geologists like to do, is explore the data on their own. So where are we going here shortly? I'm really excited about the next phase, which is stratigraphy. This will come up. We'll be able to show the well. And on one of these, you'll see the full stratigraphic chart, which we will have digitized. Most of these are on paper and from 1950, as most of you know. But we have a way to go ahead and turn that into every single layer, at what depth and what age we believe. And then we want to correlate that with the samples. And we may have many types of stratigraphy. Chronostratigraphy is available. Lithostratigraphy is available. What's another one? Biostratigraphy. We're going to put all of those side by side. And that is, I think, going to be a very good tool for oil discovery. And well, as the stratigraphy, we are going to add more samples and more wells in the upcoming years. I think we've already got 1,000 more wells planned and maybe about 3 million more samples available. So that's my quick demonstration. Is there any questions at this point? All right, well, thank you very much. Yes.
There's another feature is when you can upload your own and use the same fields and plots basically to visualize your own data.
Correct.
That's- Any question for?
Mm,
No production data. It's mostly for exploration. But that's a good one.
where would that kind of data be available? Hmm. So it could be publicly available? Okay, I'm sorry, go ahead. Hmm. No, that's fantastic. Time-based data of all sorts could definitely be added to this system. Okay, well, thank you again. Good line.
Oh, okay. So yeah, so this presentation is really kind of brief and broad overview of natural hydrogen. And so I'm going to talk about, what natural hydrogen is, why natural hydrogen, and talk about our current understanding of how natural hydrogen system works. And just one thing that IEA's Global Hydrogen Review 2023 will be out this Friday. So really the best before date of this presentation is tomorrow. I cannot guarantee the safety of using this slide deck after tomorrow. So just a caution, but I can guarantee the quality. The quality is good. So, okay, so I will start with just giving a context. So hydrogen, the current main use of hydrogen is really a feedstock in chemical and petrochemical factories. But in this net zero emission scenario, the use of hydrogen is expected to increase, and this is due to its use as fuels, like in shipping, aviation, road transport, and also for electricity generation. And another thing we are expecting is that the most of the hydrogen will be produced using low emission methods. Then now the question is, what is low emission methods? So currently, the most of hydrogen is produced using coal, natural gas, and sometimes oil as well. But most of that hydrogen comes from fossil fuels. And that low emission methods are the ones what we call blue. So the hydrogen produced using coal, natural gas, but with CCS. So that the carbon emission or the greenhouse gas emission is cut by the use of CCS. But really what we are looking for is the use of the increase in the use of green hydrogen produced using water and renewables. Okay, so, but in the last few years, people started talking about natural gas, which is supposed to be net zero carbon, net zero carbon emission. And then there's also an orange hydrogen, which is natural hydrogen, but with some enhancement. So the enhancement is that we do something and then increase the production rate of hydrogen in natural settings. Okay, so as I said, that public interest in natural hydrogen really increased in the last. Actually, this happened this year. So this is from Google Trends, and then this is the level of public interest, let's say. And you see that there's a huge increase this year. And this is due to the publication of this one, the hidden hydrogen in science. And this is publicly available, so I really recommend to check it if you haven't. but we've known about, the presence of hydrogen in natural system. We all learned about, hydrogen in ambient water. So there's no surprise, but what really changed our thinking is that it is this discovery. So there was a discovery of natural hydrogen in a huge accumulation. And then this was in 2012. And then this publication really gave us detailed analysis of this system. And then Zegonic 2020, this is really a seminal paper. It did very detailed review of natural hydrogen systems with kind of extensive comparison of global natural hydrogen occurrence. So again, this is a good paper to start with if you are interested in. And since 2021, there is international conference focusing on natural hydrogen. And this is the third one happening in Australia. I can't remember the source, but there are already like more than 1,000 registrants for this conference in Australia, happening in November. And I also get a question. So when I talk about natural hydrogen, people ask, okay, who is interested in natural hydrogen? We don't really hear about it. We don't know who is working on. And this is from their website. So this is not the list of sponsors, but this is the list of attendees. And you see that, there are so many organizations sending their people to this conference, and this may not be the complete list. It might change, in a few weeks, and then it might be nice to have, EGI here, just sending someone, right? So just an idea. So, okay, so what is natural hydrogen? So, so it is naturally occurring hydrogen, not produced through industry processes. And you also hear that native hydrogen, and then this is more popular in Europe, I think, especially in France. And you also hear this term geologic hydrogen. This is more specific, and I kind of prefer because this is the geologic hydrogen is a hydrogen found in subsurface, the hydrogen that can be accumulated subsurface. So this is relevant, really. This is the one we are interested in. So natural hydrogen, you can find it everywhere, really. And this diagram is from Milkov 2022. He looked at over 34,000 gas samples data, and he found hydrogen measurements in over 6,000 samples. And this is just to show, where you can find, natural hydrogen. There's of course a bias towards unconventional reserves because there are more samples available with the gas measurement. So, but yeah, you can find natural hydrogen everywhere. But really for us, the hydrogen found in subsurface is really the one we are interested in. So, okay, now, so we know that natural hydrogen is there, but why we are interested in natural hydrogen now? Okay, so one of the reasons is that natural hydrogen can be a low carbon fuels So even with kind of clean hydrogen with low emission methods, so yellow is the one produced using solar, and the blue is one using natural gas plus CCS. Gray is just the one produced using natural hydrogen. So that carbon emission is still high. And this is life cycle analysis of hydrogen production. And this includes the separation of hydrogen from associated gas. And it shows that, so it kind of makes sense when you have methane as an associated gas, that carbon footprint of natural hydrogen production can be high, but even with having methane as associated gas, that carbon footprint of natural hydrogen production could be still low as yellow. And if you do not have methane as an associated gas, the carbon footprint can be even lower. And it also depends on the concentration of hydrogen within the gas, produced gas. But as you see that, it really depends on the concentration and the association of the proportion of natural gas and natural hydrogen. But there's a potential that carbon footprint can be really low. Okay, another reason is water requirement. So I do not really have a good number for natural hydrogen production, but we can assume that the water requirement or consumption can be lower than these numbers because with natural hydrogen production, water is not, we don't use water as a feedstock. We don't need to split water to produce hydrogen. And I think this is something that EGI can work on. Okay, and there are other reasons, like for example, for the production of natural hydrogen, you don't need electricity. Like a lot, we still use electricity, but not as much as you use, for electrolysis. Okay, but I think the main reason why we are interested in natural hydrogen is really a cost. So these are the current numbers we have for different methods. And then this is again from an IEA. So this is 2021, 2023, and 2050. So yes, the cost of each method will decline, but well, right now, based on these scenarios, the cost won't be as lower than $1. Maybe that this blue with that with some CCS, but the cost is, yeah. So the cost of natural hydrogen production could be lower than the other methods. So that probably helps us to adopt hydrogen as fuel in the future. So okay, so this is the estimate from USGS, and okay, so with the current estimate, also based on this model, there is like tens of millions of tons of natural hydrogen in place subsurface, but of course, not all of them would be available for us. Most of the natural hydrogen won't be in the high, in a large accumulation with a high concentration, and they may not be technically recoverable. But if we assume that 1% of 10 millions tons of hydrogen is technically recoverable, then there is 100,000 million tons, no, 100,000 million tons of hydrogen is available for us. And if we assume that we just use like 100 million tons of hydrogen every year, then that should be enough for the next 1,000 years. So there could be, how can I say? So there could be, enough hydrogen for us to use natural hydrogen as a kind of, not main, but fuel for the next 1,000 years. And these are the numbers I found online. So again, these are estimates, but there could be huge reservoirs of reserves of natural hydrogen in different places on this globe. So okay, so application of natural hydrogen. So technically, we can use natural hydrogen in all the applications, all the current applications and the potential applications of hydrogen we have. But again, this really depends on where we find natural hydrogen. And it probably also depends on how cheap it will be. So the application of natural hydrogen would be really case by case. But if it's available and if it's cheap, and then if it doesn't really, if we find accumulation very close to us, there's no reason not to use natural hydrogen. So yeah. Now I want to move on to the natural hydrogen exploration. So you see that in different papers, people say that, okay, we can adopt the concept of petroleum systems to a natural hydrogen system. And and this is what we have. So the source and generation of hydrogen, we have migration, we have reservoir, we have a seal and trap, and some of them do escape. And then we also have associated kind of minerals and gases we know of. And then we have also ships. So I will start with ships because this is where we normally start, even with an oil and gas. So it is known now that we know now that the hydrogen ships are not always, but sometimes associated with these strange and geomorphological features. And, and these are actually everywhere. You can find in Russia, you can Colombia, so South America, Madagascar, Ghana. We also have them in United States. You can also find in Australia. You can find them in all other places. And many of them are associated with hydrogen. So, and there is also, there are a few methods that propose to distinguish these circular features associated with hydrogen and those which are not associated with hydrogen using satellite images like hyperspectral data. So, what people recommend is that we start with this satellite images and try to identify the areas with potential of hydrogen accumulation. So now we know the areas with potential with natural hydrogen accumulation. Now, the next thing we want to do is to identify or see if there is a source in that region. So there are more than a few dozens of reactions which generate hydrogen in nature. And these are just a few examples. So we have the hydrothermal alteration of iron-rich rock. We have radiolysis, which happens with kind of radiogenic minerals. And then we have mechano-radical generation. This is something for a structural geologist. This happens where you have a movement of crust. And then we have degassing of magmas that happens around, for example, volcano, the oxidation of magnetite and hematite that is around banded iron formations, very old ones. And then the overmaturation of organic matter, this is something for us as well, because this happens either in the dry gas window or after dry gas windows. So, and people probably think that, oh, okay, these source rocks are already overmature, so we don't have oil. But then if you go back, you might find hydrogen, which might be valuable. And then this is another one, deep-seated hydrogen. So this is the hydrogen generated during the formation of Earth, and then stays close to the core, or just or the inner mantle, and it just degassing still. So, and this is supposed to be a large source of hydrogen. Okay. Okay. So, and there are methods to identify as a source of the or the reaction of hydrogen. So this is based on the isotopic values of hydrogen gas. But as you see, that there are many overlaps. But then you also often have associated gas like methane and helium. If you are lucky, then you can use their information to really kind of narrow down the source and the reactions that is generating or generated hydrogen in your reservoir, let's say. Okay, migration. So the basic, so it's supposed to be similar to oil and gas, basically diffusion, advection, and then faults acting as a conduit. So, and then also that then long distance migration as a solute is also possible, because at depths, the hydrogen is soluble to water. But then there will be a difference because hydrogen is more diffusive comparing to oil and gas, natural gas. So, but this is the area we need more research, I think. So, okay. And this is, so the consumption of hydrogen, this is not only limited to migration. This could happen around the source. This could also happen in the reservoir. But these are things you want to consider when you analyze the natural hydrogen system, because hydrogen is, it's such a simple molecule. It's easy to digest for, microbes. So there's a huge, and we know that the microbes consume a lot of natural hydrogen. And there's also an abiotic reaction that consume hydrogen to produce other gases. So yeah, and this is not the problem only with natural hydrogen. This could be the problem with hydrogen storage. So again, this is a research area that that has a wide range of application. Okay, so reservoir and seal. So this is an example from Mali. So in this case, the reservoir is a sandstone and also karst within carbonate. And the seal is dorite. So, igneous or metamorphic rocks here. This is the same field, 2 different wells. And what I want to show is that, okay, dorite, again, the igneous or metamorphic rocks behaving as seal here. And then, but here in different well, here the seal you have is actually aquifer, so water within this breccia. So this is a huge difference from petroleum systems. So yeah, and another thing I want to point out is that this black line is hydrogen, and this light gray line is methane. So this shows that natural hydrogen or hydrogen behaves differently from natural gas in these subsurface systems. So again, this is an area that we need more research really to understand what kind of lithology works best for natural hydrogen as a seal. Okay, I think I only have a few minutes, 2 minutes. Okay, so this is this diagram is from this group. The people working in European kind of initiative, and then this shows the technology readiness for exploration and production of natural hydrogen. So 0 is just an idea, and then 9 is for commercial application. So so basically what it shows that okay, so some basic research has been done, and then now we are in a stage of really trying to understand how natural hydrogen systems work as a whole. And then we have a few examples of commercial, commercializing the natural hydrogen as a resource. So we have this example from Mali, and then we have these companies working in the United States, which already have drilled deep boreholes as an exploration for exploration of natural hydrogen. And then for regional scale exploration, we have one in Australia. So Santos and Petroleum Central Petroleum, sorry, I can't remember the name now, but they are going to drill 3 exploration wells in later this year and in early next year. So these are in progress. And then what we do not have yet is a prototype large scale production and commercial exploration. Okay. And one more thing. Yeah, so so this announcement was made 2 weeks ago. So there's funding opportunity in United States. So they are looking at possibility of stimulating natural hydrogen systems to produce or increase the efficiency of natural hydrogen production. And so one method is actually applying EDS methods that the Forge has been developing to fracture the system and then inject water. And then there are, of course, other methods. And then this announcement also includes modeling and characterization. So this is, again, something that EGI might be interested in. So the summary, okay. So I've talked about demand for natural hydrogen, no, demand for hydrogen in general. I talked about what natural hydrogen is, and then how we can use it. I talked about natural hydrogen system and exploration. Next steps for us is the first one is that you've seen the power of GIS system. You know, Christopher and Tom showed us how useful it could be, how powerful they are. So the first step is to put all the data and the information available on natural hydrogen in one place and create layers on EGI Connect. And this will be available, publicly available, because this is something I'm already doing. And then it'd be nice to share with people to, you know, to really collaborate with people. And then after that, well, not after that, actually, I'll do it at the same time. I will share all these kind of updates on natural hydrogen in EGI's on LinkedIn account or somewhere else. I haven't really decided, but we will definitely announce it on EGI Connect. So if you are not following the EGI on LinkedIn, please follow. You also get, you know, other useful informations from EGI's account. Then after that is an EGI Living Atlas of Natural Hydrogen. So this is what I want to do before things get, you know, out of control, because as you've seen, the interest, public interest is really increasing. And we can you know, expect that there will be like hundreds of publications next year. So before that happens, I want to have a place where you can, you know, where people can come and then, you know, check. So yeah, this is our next steps. So thank you.
Yeah.
Just go. All right. I'm loud anyway, so. Okay. Good morning. Are we good? Okay. All right. Well, thanks for having me speak. So I'm Bobby Mohanty. I'm a professor in chemistry and material science engineering. I've also worked with EGI a bit. And this morning, in the next 15 minutes, I know we're behind schedule, I'm going to give you a very brief overview of the critical materials and modern energy landscape. As we're going to see, this drives a lot of what's going to happen in the next 20 years. So I'm going to ask you a question, which everyone in this room probably has an answer to, but I suspect not all of you have the same answer. Okay, what are critical materials, minerals, right? So if we go through and ask the Department of Energy, this is their list. Okay, this is the list. So we're going to focus this, but if you go and look, you will find a much bigger list. So the larger list from the US Geo Institute is about 50, including these, but we're going to care mostly about these, and there's also some rare earths and things like that. So this is super important because as we think about a strategy of what we're going to do in the future, you need to focus on these. Like aluminum, for example, I would not have guessed initially, right? I actually thought, yeah, but now it's a big deal, right? So let's look at this. Most of this data is from a few different spots. Some of you may have seen this, but right now, the 2025, we're almost through that, midway through that. You can see that we knew all these, right? You knew all these, cobalt. And if we look here at the next, when it gets worse and worse, we're adding a lot, okay? This is a problem. Question is, why, right? Why are we suddenly in dire need of these things? And why do we feel like we're behind the ball, right? There's some very good reasons for that. And some of this is from unintended consequences. So we are now in an energy transition, right? You've heard this term. This is everyone's favorite term right now, energy transition, which means that we are trying to go to some sort of renewable clean energy source. And in order to get there, we are in dire need of those materials, which it turns out domestically, we have almost none. Or access, that's not entirely. So right here, mineral use in clean energy technologies, right? And on the right, here's the list. And on the left are the various clean energy technologies. If you read through the literature, read through all the reports, the main two that are actually pushing this are electric cars and wind. Wind by far has been the biggest, fastest growing renewable energy in the last several years. And now everyone knows there's a big push for batteries in electric vehicles. So for better or for worse, we're committed to this, right? And we have these goals of trying to be fully electric in 10, 15 years. Problem is, no one's talking about all of these things you need to get there, right? This is all the problem which people in this room hopefully help solve, right? That's why we're here. We want to solve these problems. Graphite, for example, people never forget that. Now, I want to point out one thing. So rare earth elements matter. The reason these are going high is because of the permanent magnets that are required. Okay, a lot of you may know this, but there's so many high efficient magnets that are required, and because we've, for whatever reason, or the economics have pushed these two forward, now we need to run these particular technologies and sometimes higher temperatures, which require very specific stabilizing rare earth elements that go into it. This is just the more complete of all the ones here. Things that in black, so EVs, battery storage, we know is big. Geothermal, by the way, needs a lot of nickel, right? So when I had gone through this, I was not aware that almost every single energy piece actually needs something, right? So this is important to know, because as we go through this, it's going to be super, super important. Nuclear is also very, very important. It doesn't need a high max of anything, but if we were going to get, everyone in this room probably agrees, if we're going to get any sort of energy with reduced carbon footprint, we're going to have to go with nuclear as well. So this gives you the big picture. Now, because we decided as a society that we wanted to go after these green energies, clean technology, well, then we have to go after the minerals that go after, which means our greenhouse gases go up. So there is pressure for greenhouses to go up while we're trying to cut it with the downstream clean energy, right? This is a problem. Now, according to the data from IEA, this is true with some very large error bars. You are probably going to be okay, maybe. If you this is comparing ICEs and BEVs, right? So BEVs are complete full battery electric vehicles, and ICEs, if we were to look at this on a life cycle basis. So now this can change, right? The high error bars are there because the method in which you get the minerals differ. Okay, everyone here, especially if you're extraction people, you know it's going to change. It can change quite a bit. But the innovation that we have to think about is how do we get those things in a more environmentally conscious way. But it's important to understand that if we're committed to clean tech, that means we're committed to rare earths and critical materials, which means greenhouses go up for a while till they go back down. The mineral requirements are skyrocketing, and particularly here, compare the two. From just in 9 years, right? Went up 50%, right? It's going to continue to do that. So the trends are pushing very, very fast and hard. This one's actually important. The energy revenue, because in the end, this is what drives everything, right? We can sit here all day and say, be clean tech, but the numbers suggest that, and according to the report, these are conservative numbers, but eventually everyone knows the revenue is high on coal and fossil fuel type stuff. But in 20 years, actually less than 20 years, if you're going after energy transition materials, because that's what we're going to call it, energy transition materials, this is actually where you want to go anyway. If you're a company, if you're any type of business, and that's where a lot of local businesses in Utah, they're all going down this path. although it's a very long forward-looking plan. So the revenue is projected to change. So we have a supply chain problem. Everyone knows this. And, you know, up here, oil, gas, well, we're sitting very pretty in upstream, right? We've been like this for a while. And we're great, but now here's the problem. We are nowhere to be found. We're good here at parts, components, deployment. We're really good there, actually. Best in the world, I would argue. This is a problem. You all know this, but I really like this graphic because it just punches you in the face. Like, what are we gonna do? Now, there are things we can do, but it depends on our approach. Most of you have seen this, right? This is from 2017, but this is our domestic critical material deposits. Deposits does not mean we're actually running any operations. I want to be very clear, okay? We have to start mines, we have to permit, just to be clear, but it's there, okay? If we care more about, you know, we're in the EGI, we look around here, well, there's quite a few things. And actually, there's stuff on this list that there's actually other stuff here that is not listed on this map. But what is the strategy we want to make, right? This is what we have to think about. We know it's there, and we know we can access it, but we have to do it environmentally responsibly. So these are things we have to really think about. If we go look a little more, you know, so this one you all have seen before. Various spots. These are, by the way, are traditional spots. I'm going to talk about non-conventional in a minute, but these are traditional spots where we can actually have access, right? If we go to our colleagues in Nevada, who we interact with, well, they're even better. So if you were to look at the United States and think about the critical material sources, I mean, frankly, you would go to Nevada and Utah. Maybe you go back east, look at some stuff from coal that might be, but we're sitting, Idaho too, actually. We're sitting on all of it here. So the strategy really, when we think about is, what are we going to do? Now, Nevada, all of you heard about a week ago, is sitting on the most lithium in the world, at least according to the article, right? Except this sign is from at the border of the Nevada-Oregon area, but there's significant resistance to actually going after it, right? And that's reasonable, actually, right? There's significant, most of you know, there's significant environmental issues when we go through these things. And they have to dig for this. You have to dig deep. Now, Nevada has clay stones, which is a more non-conventional source. So there are other things we could do. So while we think about solving this problem, oh, by the way, Idaho, we have one mine for cobalt in the United States. It's in Idaho. They started this year. I think they're shut down for the moment, and this is the cobalt belt. So getting at this is hard. And actually, the problem with a lot of this is just the information, right? EGI, you know what EGI strength is like the repository of all information. And eventually, I believe the repository of all critical material information will occur. So the government has been worried about this. Unfortunately, they started doing things in 2014, which is kind of a little late, I think we would all say. But this was been going on, Core CM. About half the people in this room is involved in Core CM, right? Where we were looking at alternative products from coal. Now, here's the technical hurdle we have. We have very little ground truth data. I was writing a proposal, and I was looking for data on tail minings. I think my next speaker will help us with that. There is no data. People just say, oh, I think there's rare earths. I think there's critical materials in there. And really? There's no, so how can you write a proposal to the US government without any data to cite, right? So then you go to a company and say, oh, we have our mining, we have our tailings. We think we have this, right? So this is the problem. There is no ground truth for any of this. So we have to build that database, which is where EGI, I believe, will play the most significant role, right? Now, we need some environmentally friendly approaches. So almost every extraction harvesting method is very water intensive, which in Utah we would like no. Unless you can use wastewater and no fresh water, right? Big problem. Also high energy, very high energy. So if you either use a solar thermal process or you use to drive the energy or find another way, right? So we can also think about new recycling approaches. And maybe some extraction approaches. That's not necessarily where EGI would sit, but just it's worth mentioning. So now if we go for unconventional sources, this is how it's defined. Anything that's 0.001 to 0.03%. I remember 10 years ago, we said, oh, we can get geofluids for geothermal well. It's going to have rare earths. And then we looked at, oh, it's how little? Like it wouldn't be worth it, right? No. Yeah, but now, yeah, PPB. But now we're like, oh, we better go back. And there have been 4 or 5 pilot projects in the last 5 years, mostly back east, where they actually looked at the feasibility of doing this. Can be done. In those processes, they're using some sort of acid leaching in most of them. But one thing you can do, which they didn't mention, is you can do phyto hyperaccumulation, use plants to bring it in, right? So that's stuff that we're working on. But the idea is that you're kind of slow, but if you get the right kind of plants, you can boost it. But then all that element is now concentrated in biomass, and then we figure out a way to extract it, hopefully environmentally friendly. But this is just to know, this is conventional is 0.5 to 40%. So this is a stark difference, but these things you can get. There's lots, everyone knows there's lots of mine waste that's sitting there that no one will touch. Well, we can go get that and try a lot of pieces. So it's not just the technology, it's the environmental hurdles right here. And I want to just highlight these. The water management, really, really a big deal. The social and health and the human rights. So in a lot of places where they do this, people work in terrible conditions. There's no safety. So it's important to highlight. And these are highlighted in the reports. So this people are aware of this, but we never talk about it, right? So we really, really need to make sure as we come up with strategies that this is always included in what we're thinking, because it's not just getting materials, also how people are treated. Do they have a living wage? Are they not exposed to toxic chemicals? Because all these things are nasty anyway, right? These are the resources that I use for, if anyone wants the slides, happy to share them. Happy to take any questions. These are all my AI generated images where I said, all right, here's my fossil fuel to, renewables, and I have a dragon in the middle who's just burning the earth. And then here we go. It's like, no, and then there's a solar car, right? So, all right, happy to take questions. Yes.
General comment.
Yeah.
The idea of actually looking at the impact of critical minerals is so key. A lot of critical minerals at the moment come from Africa.
Yep.
We're really used to seeing people washing their clothes in, uranium, contaminated water.
Yeah.
And we forget about the US.
Mhm.
And there is the same level of education in some rural areas of the US as there is in Africa. And without that community engagement and sort of really educating people about critical minerals, especially in rural parts of Utah.
Yeah.
We think about it. And
Yeah.
so, it was great to see.
And actually, the lithium deposit in Nevada, a lot of it sits on Native American land.
Yeah.
Okay, that's a big deal, and we all know that there's a history of distrust, so it's very, very difficult to actually execute that anyway. And then, and fairly, because we've broken every agreement in the past, so why would you,
Right?
Yeah. Any other questions? Yeah. Yeah. Yeah, there's a couple of approaches to to do that. I mean, I actually work on water type stuff in my lab, but we've been looking at water friendly technologies that so if you have to do, say, an extraction, so like an electrochemical extraction, maybe you could use really dirty brackish water that you were throwing out anyway. Do that first and then take it and treat without having to go to the fresh. So there's that one strategy. Then the other one is like, well, I have it going in and just treat it afterwards, right? So the first one's better because from a water rights perspective, you're not going to get it. You're not going to get it. So you better go take the waste and use it, right? If you're going to think of a near-term strategy, that's how I would start it. But then we have to come up with some innovations. But we have some ideas. Yeah.
Okay, great. I'm going to follow on from Bobby. I'm going to hand round some minerals. Woo, if I don't drop them. Hand them round, have a look. You'll see at the end why I'm handing these round. You can take them out, but you've got to find them if you lose them. Okay, so this talk is from both myself and my co-author for this work. My co-author is called Rajiv. He's a machine learning expert. We haven't got to the machine learning bit yet, but he's an important part of this project, so he's going to be listening. Bobby showed this figure, so I'm going to show it again. It's really critical, no pun intended. We have our short-term energy needs and we have our medium-term energy needs. And as Bobby said, these critical minerals and materials are key to whatever we're doing in green technology. So we're gonna refer to this figure through this talk. And we're gonna look at an area of Utah called Spore Mountain. Spore Mountain is in the middle of Utah, in central Utah. You can find it quite easily by...
Apologize for the interruption. I think we need to check your mic.
Oh,
for those
okay.
who are watching the broadcast.
Oh, there we go. Okay, does that work well? Okay, thank you. Spore Mountain is in central Utah. It's famous for a few things, as we'll go through in a minute, but I'd like to set the scene first. So our reliance on critical minerals, because of green technology and various other technologies, comes down to a few elements that we're going to discuss. And this is based on mine tailings. So what can we get out of mine tailings relative to the critical minerals that we need? The graphic at the bottom here is the import of critical minerals to the US from different countries, which is why the US doesn't have any. We're very obviously, we know about China. China has a lot of rare earths and critical minerals in general, but we also have quite a lot in South Africa, Canada, Mexico. Those are our friends. We don't need to worry about them. And also South America. So we can't forget about those. But our domestic, obviously our domestic scene for critical minerals is really low right now. And part of that is to do with ground truthing and just knowing what we have. We need to find an environmentally friendly way to find critical minerals over large areas, and then obviously move down into smaller areas to really work out if those areas have critical minerals and what form are they in. So obviously we then move forward from large scale down to smaller scale, down to things like metallurgy. There's no point having critical minerals if we can't get them out of the rocks that they're in. So how are we going to do this sort of ground truthing? One of the ways that we've looked at doing it is hyperspectral imaging. And I'll tell you a little bit more about hyperspectral imaging, but sort of imaging 101, why are we doing this? And so this is the hypothesis. Hyperspectral imaging, so narrowband imaging, has the potential to facilitate the sustainable and efficient extraction of essential minerals from geological significant areas. Tailings are great for showing us where geological significant deposits are. We already have the rocks out of the ground on the surface. And that's part of the problem with critical minerals. How can we do large-scale ground truthing if the minerals are subsurface? So tailings are perfect because they give us that subsurface on the surface that we can then look to use those analogies for the rest of those geologically significant areas. So how can we find analogous areas that we can use in other parts of the world or vice versa in other parts of the world to America to try and find critical minerals. So this is our methodology. We're going to go through field surveys, data collection, data processing, machine learning, and then ground truthing. We're going to go take samples. And this is really key because a lot of people do hyperspectral imaging and satellite imaging in general, and they don't go and get the rocks and test out their theories. So it's really important. And then using that to fusion process and then go back to machine learning and teach the models and go through it again and again and again until we get good results. Hyperspectral imaging, very useful, comes in a lot of different forms. Satellites, fixed wing aircrafts, and drones. So not only can you do hyperspectral imaging at very large scales, you can actually go down to outcrop scale with drones with small hyperspectral units on, and then obviously scale up and down that data to make sure everything's correct. Hyperspectral imaging is incredibly useful because with one sort of image or pixel scale, you can get 100 or so different bands of data. One of the things you can then do is map it into false color images and analyze that data to bring out the different units and different minerals you want to use. That's done by looking at mineralogical reflectivity spectra that then feeds back into hyperspectral imaging. You may ask, how do minerals change this reflectivity data? And it's literally down to a mineralogical scale of sort of crystallography. We're going right down to that scale. And so it really does give us good data. We just have to know how to use it. And this is how you use it. So this is like overwhelming. And we just see the end sort of output, these very nice mineral maps. That's great, but it takes weeks to get to that point. And if you mess up this bit, none of this is useful. So we have to be really cognizant of how we're using the data and how we're taking hand samples and outcrop samples and tailing samples, and then actually analyzing those to get decent reflectivity data to actually put back into the hyperspectral imaging. So the methodology, I've introduced this before, but I wanted to just show how that previous figure, that flow chart of hyperspectral data processing fits into this methodology. And as you can see, field surveys are fairly basic, literature review, location evaluation, and then through the data processing, the ground truthing of taking minerals, the processing, and then going back to the data processing, machine learning, and bouncing back and forward until we get good data. So Spore Mountain, a lot of you know I like taking photos, and I happened to be out here a couple of years ago actually helping a friend look at gold prospects and red beryl prospects called Bixbyte. So I was here and I didn't realize that years later I'd be looking at this mountain range. This is Spore Mountain. And so Spore Mountain is super useful because it's got a really long history of mining. You can see some of the mine workings here. Down in here, actually, you have quite a large uranium mine called the Yellow Chief mine. And then up here, you mostly get fluorspar beryllium deposits. This, for anybody wondering why this is so kind of dirty looking, we had a lot of wildfires. So that's why the moon is red. But it's very useful to show this entire mountain range. And it's great to use as an example because it's a discrete little mountain range. And it actually kind of just pops up after the topography, and it gives us a perfect sort of target for hyperspectral imaging. Like I said, we've got a nice uranium mine here, and this is a fluorspar deposit. Bobby showed this map, and I'm going to show it again. This is tailings in Utah, historic mining districts. Spore Mountain is the red blob. It's really useful to look at because it's quite basic geology. But it has a lot of associated critical mineralization relative to its geology and to its size. It's a small range, but it has a lot of potential. And because of that potential, it also gives us a great potential to have an analog for critical minerals evaluation using hyperspectral imaging. And of course, ground truthing. In 3D, you can see these tailings really, really clearly at the side of Spore Mountain. there's really extensive tailings right across. And up here, these are beryllium deposits. So we already know that we have beryllium and uranium, and then the associated mineralization to fluorine as well. So the critical minerals that we're going to look at are these: the uranium, lithium, dysprosium, beryllium, and then a few rare earth elements as well. They are all up here. A critical need of critical minerals. So what do we use critical minerals for? Again, Bobby kind of covered this, but I'll just go over it for the purposes of this talk. We have sort of 6 main different industries here. And the elements in red are those minerals or elements that are going to be really needed by 2035 to 2040. If you then look at Spore Mountain are the yellow spore stars. We have a huge number of those in a small area. So again, perfect test scenario. The methodology for this project, which we'll hopefully go ahead with, is to define the study area, acquire the hyperspectral data, process the hyperspectral data, as you've seen in that giant flowchart, and then the spectral identification and mineral analysis, and then the mineral maps. We can do all of this with just the satellite data, but what we'd like to do is then use the fixed wing aircraft and then drones as well. So one of the things we're looking at EGI is getting a drone unit of some kind to run hyperspectral imaging over smaller areas with much better resolution. As I said, we can use the study area, satellites, critical minerals, and tailings. These things are all really well linked, and Utah is a perfect place to study this, which is great. So some images. I think everybody likes to see hyperspectral imaging. It's always really pretty. That's one of the things which is nice. So VNIR, Aster imaging, and VNIR, it's near infrared, visual near infrared images. So with hyperspectral imaging, we're in the visible spectrum and just into that infrared spectra. So it's very useful to combine those, and we can reconfigure the bands from the different satellites together and then use that to identify these critical mineral deposits. If I overlay the geology on here, you'll start to be able to pick out the critical mineral deposits, which are here, and then on the backside here as well. If we look at hydrothermal mineral alteration, you can see again that we start to pick up these tailings. And that's a great sign. We obviously want to pick up the tailings in our hyperspectral imaging because those tailings are associated with our critical minerals. Mineral alteration, these are reconfigured band ratios, and now you start to see the detail in here. And the next thing we'll do is start to query these images for the per pixel data. And that's where the machine learning comes in. Because once we have per pixel data, that gives us reflectance spectra for each pixel, which tells us about the mineral content, which we can then teach the machine learning models and then re-put in that data each time. So once again, you can see the geological map. I wanted to show you what it looks like before though. These are some band ratios for each of R, G, and B. So it's very basic actually to put these together. But where you see very limited information in these 3 pictures, you can start to pick out some. So the brighter areas in these are those with the higher concentrations of these band ratios. When you put it into a color image or a false color image, now you start to pick up the detail. So we're looking at beryllium. So beryllium here is in green, and you can see it lighting up. Beryllium in this area is really important because it means red beryl. Everybody loves red beryl, it's very expensive, and so this could actually show us where the red beryl deposits are, which is a little scary as well because people go and try and find that stuff. What are we going to do next steps? So as I said, we're going to go and get some ground truth data, hopefully, and that means validation sets, geochemical data, mineral maps of hand samples that we can do in-house. And we can start to tie other geochemical data into this as well. You know, handheld XRF, XRD, you know, all of this can also be put into these models to increase our understanding and ground truthing of critical minerals over large scale areas. Also remote areas. that we can't get to. As I said, next steps are dataset analysis, reflectance data per pixel analysis, and then using other satellites. We've got Hyperion, Prisma, which is an Italian satellite, Worldview and Sentinel, also very useful information again. And this is Spore Mountain in 3D. Again, you can see these tailings. Tailings are super useful. Thank you. Questions, if anyone has any.
Our final presenter before we conclude this session with the panel discussion will be Dr. Rasul Sarkabi, talking to us about petroleum exploration.
Sorry. Okay, thanks, Brooke. I have a challenging task to do because I have so many slides. So I will rush through some of them for the sake of time. So this slide shows the core competencies, the domain expert domains that we have at EGI, mostly used for petroleum industry, I would say, but also, you know, for other energy technologies. So our group of energy fluids and minerals, we cater three, I would say, areas of activities. The CA program, which Chris Kester presented, the ICORS database. So my talk, this present talk will focus on some exploration projects. These are some regional projects we are either doing or we are planning to do. Guyana-Suriname Basin Study, Red Sea and Gulf of Suez Basins, East Africa, ultra deep water oil fields, source rock organophages prediction using machine learning, which H is leading that, gas basins of Africa and shale studies. So I don't know how far I will be able to cover this, but Guyana-Suriname Basin Study, this is one of the, I would say, hottest basins in terms of exploration and production. So outside of shale, let's say, for the past, I would say, 7 years or so, this basin has had the highest growth in terms of reserves globally. So very important. So this is a new project that we, actually the report is ready to go. So we have lots of geochem data and other strat data, et cetera, paleofacial data, et cetera. So this is the price tag. There are lots of industry wells. Those of you who have worked in this area, most of these wells are exploration wells, pre-Lisa discovery. So very precious in terms of the data. Another region we are working on, Red Sea, Gulf of Suez Basin. This has a high price tag because we have lots of reprocessed seismic and well logs, SEGWI and LAS files. This is a project which we are starting. We have identified lots of wells. Basically, we are looking at the correlation of petroleum basins, especially oil gas to source correlation, source rock correlation. Again, those of you who have worked in this area know that the oil to or gas to source correlation is a huge, huge problem, especially offshore. So this is something that we would like to do. Also extend the East Africa offshore and also Rift Basin all the way to Oman. Because if you close the Gulf of Aden, basically you end up with a single margin. And usually the exploration units in oil and gas companies, you know, they are regionalized, so they rarely think of comparing Oman with, for example, Mozambique. But this is something that we would like to do. So these are the countries that we'd like to cover as part of this project. Another project, actually, Dr. Tony Dore, who has kindly agreed to moderate our panel discussion, he came up with this idea. to look at ultra deep water plays. And the motivation for this whole analysis, new analysis, comes from two major discoveries. Offshore West Africa, Total and the companies. So that's the motivation. So you have deeping reflectors, but then, so it's oceanic crust, but then you have petroleum system sitting on top of this relatively cold oceanic crust. So how does that work? And where else we can find similar plays and prospects? So that is the motivation for this study. My colleague H, who presented hydrogen, he put together this map. It shows where else I mean, this is basically our database in terms of wells and basins that we can look into. So that's the methodology. We will be using all sorts of data, geophysical, geochemical, et cetera, et cetera. So these are some of the key questions. What is the impact of continental margins and also the basement, oceanic floor basement structure and the thermal evolution on the development of this particular like source rock, reservoir rocks, et cetera. Also source to reservoir migration. So these are conventional fields, right? Not shale. So there's a migration factor. So where would the source have been? So this is a very important question. And also compare and contrast these different plays. Then the end product will be an atlas of plays where you can compare different concepts, play concepts. Actually, we are also hiring a postdoc, hopefully by the end of this year, to work on this particular project. This is a project that, again, Dr. Setoyama is leading to characterize the organophages using both pyrolysis and also kerogen visualization techniques. He has collected lots of data, both EGI data and also from the literature. This is, again, he's here, so he can answer to your questions. This would be like a routine pyrolysis. But the problem is that with the routine pyrolysis, you would underestimate HI, hydrogen index, especially if your TOC values are lower than 3%. So the whole idea is how to use, again, machine that has been trained to pyrolysis data and also kerogen visualization data to come up with more realistic, more accurate HI and also TOC and other pyrolysis data. This map shows the database that will be used for training the machine learning component of that. As you can see, it covers Paleozoic and as well as Mesozoic rocks. So this is the workflow for this, and the cost is $40K for non-CAs and $32,000 for the CAs. Gas basins of Africa is another project that H and Brian and others we have been working on, Chris. So some work has been done. So the idea is to put together really an ArcGIS platform where you have both upstream, exploration, E&P, as well as the infrastructure data. Now, with Africa being close to Europe and with all the political conflicts happening in Europe between Russia, so this would be a good database to use by oil and gas companies who are interested in tapping into African sources. As you can see, I'm rushing through just, so this is the map of our regional projects at EGI, and the suggestions are welcome. My last topic is the shale studies. So this is for North American, oil and gas companies, especially in the US. I'm sure you are all familiar with the shale revolution. This type of growth, like, from about 6 million barrels to 12 million barrels within 10 years. This is a huge, huge growth, unprecedented in the past 50 or 60 years. So this is all because of shale, right? All because of shale. So one of the things we'd like to do is, I started working on this project years ago, but we haven't really finalized to put together a source rock data, basically, for all the basins in North and Central America. So we have already identified about 20,000 wells. So it's a huge, huge database. Another aspect of the shale studies, Dr. Palash Panja is here. So for the past 5 years, we have been working on what we call reverse engineering. Basically, we are taking production data and then reversing it to petroleum system elements. Again, something that, usually we don't think of doing that because engineering and geoscience is two different compartments, but that's what we are trying. We are taking the production data and then see, okay, where the sweet spots can be and why. Okay, so all the way to petroleum systems. We have already presented and published 4 to 5 papers. This last month at Image Houston conference, we presented one of them. And actually the presentation was selected for a featured story in the AAPG Explorer. So you can access this August issue of the AAPG Explorer. One of the things which we did as part of this study was to rank the shale plays in the US based on their performance. And believe me, you get lots of geoscience insights from this. I will give you one example. For example, Wolfcamp Delaware versus Wolfcamp Midland. Same formation, same rock type, same age. But simply because of the basinal differences, like in terms of pressure, and as well as thermal maturity, etc. This is number one. This is one of the lowest. So geoscience insights is very, very critical in terms of finding sweet spots for shale. Now we are talking about shale re-revolution, right? So geoscience will be a big component of that. Again, this is Shale Smart. This is some kind of app that we are putting together. A part of this comes from our databases, our data analysis. Part of the software comes from a few PhD students that Dr. Milan Dev, the EGI director, had supervised in the past. So we are trying to revive those softwares, put together an app, data rich, as well as both geoscience and also the engineering components. This is my last slide. I really wanted to rush through this slide so that this is not a kind of monologue. We would love to hear from you. So thank you very much for your patience and attention. Now it's open for questions. Thank you.
And get started. I would like to remind everybody that all of our speaker bios can be found in the program book. So please take a moment to look over those bios. We have some really wonderful speakers throughout the day, and especially on this panel. I would just like to quickly introduce Tony Dore. He will be our moderator for this session. He's also been a great friend to EGI, one of our trusted advisors, and we're very grateful to have him here. And I'll go ahead and turn it over to Tony.
Well, hello, everybody. In case you don't know me, my background is in the petroleum industry. I was with Statoil Equinor for a long time. And so when I retired in 2019, I basically came along to advise EGI. So so it's a kind of retirement, kind of demi-retirement, you know. And anyway, it's been great. My home is in London, so I act as a kind of EGI Euro representative as well. But anyway, this session isn't really about me. It's really about this incredibly distinguished and, I have to say, international panel here. And as you see, the response to this session was quite enthusiastic. And so it's all rather snug down here, but we can fit them all in anyway. So the question we're going to ask our distinguished panel today and what we want to talk about is a very simple question. Petroleum industry leadership in the energy transition. Does it actually exist? How can we enhance it? How can we improve that? And there were some questions later about that subject. And I'm going to let the panel introduce themselves just a little bit later. But first of all, what I want to do, let's see if this works. I just want to show you a few scoping slides just to sort of frame the big questions that we're going to ask. And should this advance? Yeah, okay. All right, so Millen told us yesterday, he told us something very interesting. He said that in terms of world energy, we're doing quite well in terms of electricity. A third of the world's energy is now being generated from renewables. That's great. If you look at the total energy consumption of the world, not just electricity, oil, gas, and coal, fossil fuels are still incredibly dominant. You could almost look at that bottom column there and say, you know, what energy transition? And you know, so he was saying the percentage of use for oil and gas has actually increased over the last few years. And what that translates to, if you look at this next one here, I obviously have to press hard on this thing here. Why am I not advancing? Oh, I've got it. Okay. I just have to keep trying. So demand as a whole is increasing. So what that means is not only is the share of oil and gas increasing, but the absolute consumption of oil and gas is still increasing. And that's so the demand for fossil fuel is actually greater than it has ever been right now. And the demand is increasing. Tiny ripples in the supply chain can cause absolute chaos. So, you know, example was a while ago in Britain. We had minor disruptions in the oil supply chain. We had queues for gas stations all the way around the block. And there were other kinds of disruptions as well. So, so minor ripples in the supply chain can cause chaos. And those activists that say, okay, just stop oil, what they're actually saying is if you just stop oil, basically you just stop civilization, because right now civilization is running on this. So again, it's resisting my attempts to go forward here. Is it, yeah, okay. So just press that one, yeah. I'll say next. Okay, Sid. Yeah, all right. Of course, what that translates to is pretty good profits for the oil and gas industry. So this is a super major. I'm not going to say which one it is, but the green color might be a giveaway. And anyway, this is all publicly available data anyway. It's all on the net. And what they're showing is that the profits in 2020, of course, took the massive dip during the pandemic. Everybody was hit. 2022, the profits are actually record high, historical record high. And only a tiny, tiny amount of that profit there for this particular super major, and it could be any super major, it's the same for all of them, is coming from renewables. It's almost all coming from legacy oil and gas production. Next one. So why are, sorry, so could you go back again, please? Yeah. I just want to make the point there that although the profit is being made entirely from legacy oil and gas production, if you look at the forward spend for this particular company, 18 billion budget, half of that is going to be spent on energy transition projects. So all the money is coming from oil and gas, half of the forward budget, half of 18 billion, $9 billion has been spent on energy transition projects. So next one. So why are oil and gas majors embracing the energy transition? Why are they doing it? Well, what most of the public think, and certainly the activists think, the Just Stop Oil people, is good optics. You know, that's they want to be seen to be the good guys. People are painting the oil industry as the bad guys. They want to be seen to be doing something. But I would put it to you that $9 billion is a heck of a price to pay for a PR exercise. So it's not just the optics. More likely, it's number two, good business. Because the energy transition is coming. Whether these companies like it or not, it's happening. We're moving to different forms of energy. The world wants this. And therefore, being part of that process is incredibly important. That's why the investment's taking place. There's another thing, the last thing. I was in Equinor, and most of my colleagues there thought it was the right thing to do. They work in oil and gas, but they accept the need for a transition. They accept the need that eventually we're going to have to phase out oil and gas and move to renewables because of the environment, because of their perceptions on global warming and so on. So I would put it to you that many people that work in the oil industry think that it is the right thing to do. So next one. And so the difference between the people in the oil industry that think it's the right thing to do and the activists is that the oil company people realize that you can't just switch off production overnight, because if you do that, it's a recipe for social chaos. So there's lots of thinking on how the transition could be facilitated. And this is a beautiful slide done by Bryony, who talked earlier. And Bryony's perception here, and indeed quite a lot of our perception, is that the natural gas might be the transition bridge from where we are now to where we want to be at 2050, where we want to be in the future. And that's because natural gas has got fewer particulates, and because natural gas produces less carbon dioxide than the other, than coal and oil. But that's just one perception of how it might happen. The one thing we know is that we can't just stop. We have to go on to, we have to phase this, and it's a nuanced situation. That brings me to my panel. And the next one, please. So I'm going to ask some questions to the panel about this, around these questions. And what I'd like to do is ask each of them now to just say a little bit about themselves, a little bit about what they're doing, and perhaps how what they're doing now impinges on the energy transition. So perhaps we'll just go in order along here. So Sid.
I've been in Utah since 1970 and have been affiliated as a friend and a supporter of EGI since it moved here in the 70s. I was president and founder of TerraTech, a company that was housed right next door to this building for years. And that company was acquired by Schlumberger, and then I retired from Schlumberger in 2015 and began to look at energy in a broader sense. So I have been looking now at the energy transition and what's going on there.
Yeah, Christy.
I'm Christy Micklin. I manage a group called Fluid Characterization in ConocoPhillips, and we're the geochemists and basin modelers. We support quite a few of the energy transition activities, but we also importantly support achieving our net zero ambitions for our own operations. As you saw on the plot, there's a lot of oil and natural gas in the energy transition. We need to be operating in a sustainable manner ourselves in those areas as well, as looking into new energies and new opportunities in the energy transition.
Okay, Sid Jones.
Yeah, good morning, everyone. I think I've met most of you at this point, so it's very nice to see all of you from this perspective.
Yeah.
Also, thank you, Tony, for the international welcome as a Texan by birth and by choice. I appreciate being here in the other 49
country,
for a
right?
while.
Yeah.
Yes, exactly.
Yeah.
In any case, so I've been with Chevron for about 20 years, mostly as an oil and gas explorationist. About 2 years ago, Chevron stood up a separate company to examine its strategies and choices for this new energy transition. And as part of that, they needed someone who had good experience leading the exploration and new ventures type efforts to capture some of those opportunities and to characterize them initially. And as they looked around for somebody who was maybe not too bright, but worked really hard, they found a volunteer, a voluntold, and I have been faithfully fulfilling that position for the past couple of years and helping geothermal and hydrogen storage and carbon sequestration to fulfill their exploration function. And that's kind of me right now.
Okay, now, thank you, Sid, and our guest of honor today, in fact, John Baza. Would you introduce yourself?
Okay, well, I'm John Baza. I'm the director of the state's Division of Oil, Gas, and Mining. And our organization runs 3 regulatory programs: oil and gas, coal mining, and then all mining other than coal. And then we have a non-regulatory program that deals with abandoned mine hazards and closures of those openings. But I really feel exceptionally honored to be here, because most of the time people don't want to hear from regulators, right? But I really do feel, because of our role, and we are in the Department of Natural Resources. So that involves 10 different organizational units. Office of Energy Development, Greg Todd is here. UGS, Utah Geological Survey, Bill Keach is here. I think we all work together to address the problems focused on Utah. We're very Utah-centric, obviously. But in terms of the energy transition, we would like to feel that if you're going to do work in the state of Utah, you need a license, you need a permit, you'll come to us first, and we can help facilitate that development, whatever it might be. So as we look at energy transition and how interconnected all of this is, we feel that our agency is going to be a catalyst for whatever happens in Utah. I can't predict the future very well, but I think that we would like to still think that you're going to come to us first. And even in the renewable space, we can see an opportunity there that our agency could be very helpful with because of our experience in the regulatory world. So that's our agency, and that's my representation today.
So there's the message: DOGM first if you want to work in Utah. And yes, we'll definitely do value the regulatory input. John, it's great to hear you. Bill Gould.
I'm probably the outlier here. I've spent most of my career, actually all of my career, in the utility industry, essentially leading teams that designed and then constructed power plants of different types. In the early part of my career, that was nuclear power plants like San Onofre and Diablo Canyon, and some foreign power plants, coal-fired power plants in the United States, and then refinery modifications here also. But for the last 30 years, I've been managing transitions, not for the oil and gas industry, but for the utility industry, and building the renewable projects that we talk about in general. And actually, it's interesting attending yesterday, listening to the challenges facing the geothermal folks. It felt very familiar to things that I experienced years ago. I'll just tell you about 2. One is, we were looking for someone to finance a large plant expansion, a plant of at least 100 megawatts. We talked to various venture capitalists, and they would give us money in exchange for most of our equity. That wasn't attractive. And then we approached other banks, financial institutions, environmental institutions. One day we decided to talk to Warren Buffett. We knew he owned a utility, and perhaps we could sell one to him. And we made our best pitch, and he said, thank you, but no thanks. And the reason why is his criteria were that he did not accept any technology risk. How's that defined for him? Well, he said, come to me again after you've built 5 plants and operated them for 5 years. The concern, of course, for folks like that is, are they going to get their money back? And their money needs to go for 20, 30 years, according to plan. I was thinking about the geothermal folks yesterday talking about, are we sure that the reservoir pathways will stay open for 30? Well, you know the problem. The other interesting experience I had was related to a question that John was asking his panel yesterday afternoon, but ran out of time. That is, he was asking the geothermal folks, have you thought about hybridizing with gas? I wish I could have heard the potential answers. Many years ago, I had that same question. We were pitching a commercial scale, meaning 100 megawatt solar thermal power plant to the utilities in the West. We wondered about hybridizing with gas also, because obviously the sun goes down at night, which meant that we had to cycle our Rankine cycle power plant every day. And that either consumes a lot of energy to keep everything hot, or it potentially shortens the life as you cycle and go through all those transients. So I said, I went to see the head of the research and development department at Southern Cal Edison, which in that day was a fellow named Joe Reeves, who managed about 80 folks, scientists that had in that day the charter to be able to invest in prototypes and demonstration projects. And I said, do you think we ought to put a gas burner next to our solar field? And he said, Bill, you're not thinking about this right at all. You're thinking selfishly. You're trying to solve your problem, not your customer's problem. I asked him what he meant. He said, well, obviously the solar is intermittent, so some type of hybridization is right. But the real question is, do you hybridize at the plant level or at the grid level? He said, look, I've got 35 or 40 large capacity, high temperature, state-of-the-art gas-fired power plants across our system. Their efficiencies are as high as you can get in this industry. They are an order of magnitude larger in scale. If you put a 100 megawatt gas burner on your plant and operated it 50% of the time, I don't want it. He said, I've got plants that I've got base load operating at the highest efficiency possible. Why would I want something less efficient operating half the time? He said, you got to think like a customer, not like a developer. Anyway, I thought that might be helpful to folks in the audience.
Think like a customer, right? Lastly, thank you very much, Bill. All the way from Italy,
Yeah.
Francesca.
Yeah, good morning. And thank you, first of all, for this opportunity and sharing ideas on these topics. My name is Francesca Salvi. I came from Milan. I'm a geologist. My current position in ENI now is as a head of geological and geophysical studies. So I have the opportunity to follow all the subsurface modeling from a geological point of view and integrated with the geophysical as inversion and seismic characterization, supporting all the traditional hydrocarbon exploration production activity, but during the recent year also in decarbonization activities. I have to admit that I do agree and I feel totally in line with your slides and the reasons also why to embrace the transition as company. From a G&G point of view, what we do is to improve our skills and technologies in the subsurface modeling, combining with the technologies, supercomputing, AI, machine learning, in order to de-risk and reduce the environmental impact. Plus, we are declining our skills and adapt our methodologies for the carbon capture. Now we have two main projects in Europe. And from a research and screening side, again, G&G studies, we are considering and investing in all the arguments we have seen so far: geothermal, hydrogen as natural research and storage in subsurface, and critical minerals, both in water, disposal water, for example. That could be an excellent example of a circular economy, and rocks as well. But again, always in order to figure out the minor impact in environment of all these new cleaner energy needs.
Excellent. That's a perfect lead in. Thank you, Francesca, to my next slide. If you could just advance it one more time. So you can still see the panel up there. I've got some big questions for you, though, and they relate to what Francesca was talking about. So remember, this was called leadership. So first question is an obvious one. Is the oil and gas industry actually providing leadership in the energy transition? Remember, oil companies are kind of hiding a little bit behind the bushes at the moment. Everybody needs oil and gas, but people don't want to talk about oil and gas. So are we actually providing leadership? Or is it abrogating responsibility, or even worse, greenwashing? In other words, these projects are just to sort of improve their image. And a related question then, okay, so are we providing leadership? If we are, what else should the oil and gas industry do that it isn't already doing? Now, Francesca, in a way, has already stated a case. Can I ask some of the other, I'll start with some of the people on the panel that are directly involved with E&P, with the oil industry in E&P. Christy, maybe you'd like to comment on those questions.
As I mentioned earlier, it's our responsibility to produce sustainable barrels. And one of the focus areas that our company has is investing in technology to try to reach the ambition of zero emission facilities, for example. We were an advocate for export of natural gas to reduce flaring. The more fluid we keep where it belongs and keep those emissions from happening in the first place, that's an area that we all need to be investing in and responsible for. We can't be chasing other technologies to improve the sustainability of the energy industry without, looking inward ourselves into what are our operations, what are our practices. And so, although we do have investments in carbon sequestration, in hydrogen, we also are expanding and diversifying our LNG portfolio, liquefied natural gas. We're also investing in our net zero ambitions. We're also looking into ways to more responsibly manage water. We had one of the biggest produced water recycling programs in the Permian long before a lot of other companies were getting there. So I think it's important that we don't forget our responsibility and obligation within our core business of E&P as we go through the energy transition. And so I think it's important that our investment also represents a large portion of our investment is focused in those areas as well.
But would you say the kind of spend in ConocoPhillips is in the same sort of ballpark as the one I showed earlier, the example I showed earlier, the forward spend?
I would say I would say to the point of focusing on our net zero ambitions and improving sustainability, reducing footprint, that we do have significant investment as well in those areas. It might not be directly in carbon capture sequestration, it might not be directly in hydrogen, but if you consider oil and gas as part of the energy transition, then I would say we do have a significant research focus and investment in improving our operations of the majority of our scope of work.
Good. Yeah, so Sid Jones, you might also want to comment on that. And could you also maybe address, when you go through that, doing these things is one thing, public perception is another, because this is about leadership, right? And that's so leadership implies global leadership. And so maybe you'd like to take that on.
Yeah, absolutely. So first of all, thank you for the question. And I'll also completely support what Christy just said, because we are pursuing being good stewards of the resources that we already produce. And a lot of our efforts go devoted to that, but that's us taking care of our own business. Mm-hmm. All right. We also, if Chevron has been something that you guys have followed in the news, we have been very slow to announce what we were doing in the energy transition space compared to the other majors. The reason for that is, my opinion of the reason for this is that if you pay attention to what Chevron has expressed itself to be, okay, we say that we are an energy company. We are not an electricity company. We are not a utility. As BP and Shell and some other companies made major moves into solar and wind, we still kind of stood back in the background and we're kind of watching and thinking about what we really were. We deliver chemicals so that people can live better, okay? Whether that's natural gas for electricity, we don't actually produce the electricity, we produce the natural gas, or paint or plastics or whatever we produce out of our refineries. Those are the things that we produce, and that's where our expertise is. And so it took us a long time to really build a vision for how that was going to fit into Chevron's future. What we have done since then is 2 years ago, we stood up an internal separate company called Chevron New Energies. We set aside $8 billion for the next 10 years of spend. And then we set goals to ourselves for genuinely offsetting the carbon, not only that we produce, but that our customers produce also with the chemicals that we deliver to them. And those are, we've made some big promises. We run the largest sequestration operation for the past 15 years in Gorgon in Australia. We need to build another 20 of those to meet some of those obligations, and not just from a perspective of sequestering and produced carbon, but also just offsetting carbon so that it doesn't get produced in the first place. And that's one of the areas where we're exploring hydrogen, we're exploring geothermal, and have again actively set aside, not knowing and admitting to ourselves that we don't know who the winners are going to be in this technology race, and investing in all of those areas and showing up at meetings like this to express that we don't know who the winner is going to be, but we're going to put a little bit of money and a lot of attention into all of those. And then the second part of my answer there is from a leadership perspective. The other thing that we've recognized is that while there are a lot of crossover skills, because it's actually the human beings doing the work that actually produce these resources, while there are a lot of crossover skills between the traditional oil and gas industry and these new endeavors, one of the things that we recognize is that a lot of those skills are aging out, they're retiring, they're being retired, and we need to do something about that. And so you have also seen Chevron renew its interest in not only providing internal training, but also in its participation in external programs for education, for training in these technical areas. And I think that you'll see more of that as an intentional part of this energy transition going forward. So.
Yeah, great answer. And when you're talking about reskilling and so on, about geoscience skills, I know that Francesca's got a lot of energy around that too, about the geoscience as a discipline and how that's changing. Is that another aspect that of leadership that the companies can provide?
Yeah. I think so. During the last years, I have the opportunity to direct a geoscience master internal of our company. And during the organization and the promotion, we do decide to go in the university to talk with the people. As you know, in Europe, the public opinion about the oil and gas and all the energy stuff is very hard. The people and the academic are reporting a strong decline of the students because there is this connection between the oil and gas and the climate change and global warming. So we do like to face-to-face with the young people and try to give the correct communication, the correct information, not the solution, because we do not have still the solution, but the correct information, and to pass the complexity of this so famous energy trilemma. So you do not have an on-off solution, you do not have an overnight solution, but the main message to me is that the earth science disciplines and the students can play a fundamental role in this transition. We have seen all the topics are geo-resources related, subsurface related, environmental. Who better than who learned how to observe the environmental, to respect, to study, collect data, analyze, can give a good contribution for the transition in respect of the environmental. So yes, we do also with academy take a strong contact with the young people, convince them to react and promote and suggest the solution as well.
Yeah, but you wonder how that message is going to be got out to the public as well to change the overall perception and bring more people into the science. I don't have the answer to that. I wish I did. It's one of my main concerns at the moment, you know, and I know it's one of Rasul's main concerns as well, you know, geoscience and the role in the energy transition. And that's not going to be very good if geoscience is actually declining as a discipline. Right, we've not just got E&P people here, we've got, as we established earlier, we've got utilities representatives, service company representatives, regulatory representatives. So I'd just like to ask now some of the other members to reflect a little bit on what the oil industry is doing in the energy transition and these various efforts and this investment, and is it effective, and how is it perceived, and how does it impinge on what you're doing? Maybe John can start, and we'll go on to Bill, and then I'm going to put Sid last because I know he's going to challenge some of these initiatives. And I think it'll be very interesting. So John first.
Sure. As I said, you know, my view is very Utah centric. And when we talk about transitions, Utah has gone through its own transition in the last 20 or 30 years. We don't have major oil companies operating in the state anymore. I wish we still had Chevrons and ConocoPhillips, but we've moved down a level. We're at least mid-majors, larger independents. And because of that, we see that their view of the business world is very different. I think they're taking a lead from the majors and knowing that publicly held companies have to be answerable to their shareholders and the general public. But I think they're also concerned about that bottom line. And right now they're making a return on investment on petroleum products that are being pulled out of the ground. So I think we need to continue that. And as your slides showed earlier, we can't walk away from a fossil fuel industry, whether it's Utah or anyone else. You heard from the former state legislator yesterday that what makes sense in Utah is what makes business sense. And I think that's going to rule the day for a state like Utah. But I would tell you this, Utah has, amongst petroleum producing states, we have the largest percentage of federal land. We also have 2 Native American nations in the state of Utah, at least 2. There are other smaller ones as well. And you could almost look at these as international partners in a sense. So I've always told people, if we can find a way to make these industries work in the state of Utah, it can work anywhere in the United States, because we can clearly find solutions to problems that can serve as models elsewhere. The last thing I'll say is something that Sid brought up, and that was the decommissioning of these units of oil and gas or power plants or whatever it might be. I think we have good experience with that, and part of it is having the vision to look down the road and say, well, how do we prevent a liability to the citizens of the state? If you look at the orphan well count throughout the United States, Utah has one of the lowest. And part of that is 30 years ago, there was an attitude that says, how do we manage the idle wells in the state so we don't end up with a huge orphan liability over time? So I think all of that is part of transition, is to have the foresight to look down the road and say, what are the potential problems that are going to exist in the future? And what steps can we take today to address these things? Good friend of mine from Oklahoma, who used to be the Secretary of Energy there, said, if we can see a problem that's going to happen 10 years from now, today is the day we have to start working on it. So hopefully we're doing that in the state of Utah. And as I said, it has to be a collaboration across government entities, federal government, the companies that work in the state, as well as the Native American tribes that exist in the state.
I can't think of anything more worthy than Utah being a kind of microcosm for the United States and indeed for the world, you know, because I think the things that you've said might apply to Utah, but they're kind of universal as well. Bill, you actually helped to frame one of these questions here. I used some of your words what do service industries and utility companies need to transition to a greener future, and how can the oil and gas industry help meet these needs? I don't think that's what's precisely your question, but maybe you'd like to talk around that.
Let me make one related comment first.
Yeah.
There is a clear difference in urgency and time constant of change between the oil and gas industry and the utility industry. It's not that the utility industry is more willing, but that the government has imposed shorter term deadlines on the utilities. I want to illustrate that by just wondering if you have seen the EPA proposed new carbon pollution standards for fossil fuel fired power plants that came out this summer, in which they proposed to limit everything to 90%, a 90% reduction of carbon dioxide from coal and gas fired power plants, and have that occur for gas plants by 2025 and for coal plants by 2030. Now, many industry groups are saying it's impossible, and I would agree with that. But you see there's a deadline. Now, I think because of the intractability of reducing carbon from transportation fuels, that's a long ways out. We don't see people trying to take 90% of the carbon emissions out of gasoline within 3 years. We talked yesterday about the difficulty of trying to make a financial gain if you have a carbon tax that is so low. And frankly, with our fractured political system, I don't think we'll ever get Democrats and Republicans to agree on a carbon tax big enough. But they don't have to. If by regulation, you can impose these requirements, whether they be mileage standards for Detroit or carbon emission standards for the utilities, it'll have the same net effect, and without the political unity that would be required. My comment is simply that there is an urgency being imposed unwillingly on the utilities that I haven't quite seen yet in the oil and gas industry.
It's very interesting what you're saying there, because you threw restrictions, and yesterday said from Chevron of all people through carbon tax, we're actually sort of in a way advocating artificially boosting some of the alternative technologies at the cost of the traditional ones. Does everybody in the panel stand by that idea? It's a. Sid, do you want to come in one more time? I'll go to.
Well, so that was originally Eric's comment.
Was it?
Yes, it was.
Oh, it was Eric. It wasn't Sid. Yeah.
However,
it was. So it wasn't.
You know,
I just apologize. Yes, it was Eric.
I absolutely agree that there has to be some strategy for approaching this that actually puts the cost of what we are doing in the right place. Right. A tax like a carbon tax would certainly be one approach to it. I'm not going to pretend to know. I'm not a policy expert by any means, but it does certainly seem like, you know, that is one of the ways that we have of actually pushing the cost to the consumers that can actually start influencing change in the energy mix that we're actually using. So yes.
Yeah, very interesting. Okay, Sid Green, you've been very patient, and you've been hearing about the sort of many initiatives that the oil industries are taking, many options that they're playing at the moment. And yesterday you had some comments on that about the viability and about the sort of economic viability and the technical viability of those. So maybe this is time for you to come in and comment on what you've heard so far.
I was thinking that maybe I would skip over completely, but
no,
you know,
saving the best for last.
Let's see. I do have one thing I'll show you. I wrote up some comments, and I'm not going to read them now, but I have a few copies here if anyone's interested. But when you look at the energy transition underway, we hear all the things being done. We hear the panel talking about their companies, what they're doing, and the energy transition seem to be widely embraced in the media and the press and at this meeting. And a lot of things are going on, a lot of money being spent, a lot of government sticks and carrots. And yet just recently in the last few weeks, information was released for the US showing that carbon dioxide emissions are increasing more rapidly than is energy consumption growth. Now that's interesting, isn't it? All that's going on. What's going on? What's wrong? How come is it getting worse? I've been arguing for some time that the energy transition is supposed to be, I think, about reducing carbon dioxide. Not about another energy source for the sake of an energy source. We have wonderful energy in oil, gas, and coal, but they have this problem of the CO2. And yet that's been forgotten. No one here or at your companies is willing to stand up and say, let's do a complete cycle analysis and see. Now that means that's going to be, in some way, telling the emperor he has no clothes. Politicians aren't going to do that. The media certainly isn't doing that. You don't get government research money by doing that. But when you look at the things, they have to be questionable. For example, biofuels. About 4% of the US fuels now is biofuels, primarily converting corn to alcohol. It's by far the biggest biofuel. For decades, we've had information showing that converting corn to alcohol is at best neutral and very likely creates more emissions to produce. Now we're adding in the US soybeans to this, and of course you could guess which state is for that. Iowa, the biggest soybean state, is supportive. They might be. The list goes on. You look at converting EVs, and the biggest activity in the US, in the world by far globally, is China. They're clearly leading the way at converting their cars and light trucks to electric. And yet that means they're converting transport fuel from oil to coal. But most of their electricity is coal, over 2/3. And so, hey, has anybody thought about this? Then you look at nuclear energy in the US. We have about 52 or 53 power plants underway in the US, get about 20% of our electricity today from nuclear in the US. And yet we have been buying all of our nuclear fuel that we have to buy outside from our good friends, the Russians. And suddenly after the Russia-Ukraine conflict, we said we can't buy from Russia anymore. And I suspect they also said we're not going to sell you anymore too. And so suddenly we're going to say, hey, are we going to run out of processed nuclear fuel before we can get our reprocessing plants up again? Well, the most recent activity, the U.S. has spent almost $500 million to start the new plant, the Honeywell plant in Illinois, which is starting today as we speak, to enrich uranium. The list goes on. Now, why is it that we talk about all the great things we're doing and the great things about energy transition, but why aren't we looking at this realistically? What's going on? I don't know.
But what you've very eloquently illustrated there is that the situation is nuanced, that you take these initiatives, but there's a downside as well, and often the downside isn't considered. But you know, I'd fire it back. You can say, okay, what do you want to do about it? What do we do about it? What action positive action can we take to determine which of these things are beneficial and which aren't? Do you have any thoughts?
I mentioned yesterday that because that's a good question. Say, okay, Sid, what's your idea? Then what's your big ideas for reducing carbon emissions to hopefully slow down global warming? I argue, as I said yesterday a little bit, that even the rich United States has limited resources of labor supply, technical capabilities, money. Even as rich as we are, we have limited money, and critical minerals that we have to have, everything from steel, aluminum, copper to critical minerals we heard about today. And that those should be deployed or used the most effective way to reduce carbon dioxide, not to just find another energy source, but to reduce carbon dioxide emissions. That's what it's about. Well, how can you do that if you don't really understand how any given action is going to reduce carbon dioxide? So what I suggest we should do is to better deploy our limited resource, even in rich United States. And that's not being done. I mean, there's no way you can argue that is.
So let me fire this back at some of the E&P people then. So yesterday, Chris was making the point that, you know, we're doing these parallel initiatives without really thinking about scientific viability and economic viability. Now he's brought up the question that some of them might actually have the opposite effect to the one intended. So Christy, do you want to comment on that?
Well, and generally, I would like to comment that I believe that if we are not looking at things holistically, as described, we may be swapping one problem for another. So by being hyper fixated on carbon, we may be damaging our freshwater resources, which is our most precious natural resource on the planet. We may also be damaging communities through our activities. As mentioned earlier, mining can, in our traditional methods, can be incredibly detrimental to communities. So I think it's very important to look at the balance, not just from a perspective of carbon, but from the perspective of sustainability. And sustainability includes economic, community, social focus, and environmental. And if we're not looking at it holistically, we could be causing new problems or causing more harm than what we're trying to remedy. So I agree that it's very important to focus on the whole picture. Are we net benefiting? Are we reducing our footprint? Are we making the best use of our water resources? Are we enhancing the lives of the communities in which we operate? If we're not considering all of those impacts simultaneously, we could be making the wrong overall decisions.
Great. So Sid Jones or Francesca, do you anything to add to that?
Please.
Yes, okay.
Happy to provide an example. So first of all, I'm not going to repeat what either Sid or Christy said. 100% support what they're saying. Just to kind of drive that home, let me give you just a quick example around Chevron's publicly stated geothermal strategy. So geothermal is a great energy source where it works. In that, especially that it provides essentially a zero carbon electricity production. However, it's very reliable, but again, limited to certain geographic areas. So one of the questions that we've asked is, you know, and to look at it from a slightly different perspective, right, is that from a carbon impact perspective and from a total value chain for our shareholders, what makes the most sense? You will not see Chevron, except for some very limited situations where we're mostly testing things out. You will not see us become a utility company producing zero carbon electricity for other people. What you will see us doing is choosing very purposely some full value chain production of utilizing that zero carbon electricity to then produce end products for users in highly carbon intensive environments. So just as an example, fertilizer production uses a lot of natural gas. If we can offset the part that the gas that we are burning to produce that fertilizer or ammonia or several other critical chemicals that the world needs, then we're actually providing the most effective energy production, carbon offset, and value at the very end of the day. However, that only works where people are correctly attaching the cost of carbon to the chemicals that they're producing. So if I then sell that fertilizer to China, there's no uplift. If I sell it to Japan, which does recognize a carbon credit for how that fertilizer is produced, then I actually, I attach the value to the product, and I make money for my shareholders. And that's really going to be kind of the way I think that the future is going to work. Is we're really going to have to attach the value to the and the full value, right? Not just the dollar value to the products that are being produced and consumed across the globe.
Yeah, thank you very much. And did you have anything to add to that, Francesca?
I totally agree. So what we are saying, in other words, and we agree also from my perspective, but also for my company, is that it is a global challenge and has to be addressed in a global way. Yeah. So from our side, what we can do is to reduce the emission. We have the target of net zero. We have to admit that we need gas in order to invest for the new future and technology. So for a while, even if it's not the best, we need fossil for a while, but in a better way. But this so-called again trilemma, so the sustainability, the equity, and the energy security has to be addressed for all the perspective, from the social, economic, and environmental, and in a global way. Otherwise, so only one community address this issue, the effects are not so real. So we have also from a political and government point of view to act in a global again way.
So, talking about the pros and cons of these various alternative energy sources and options, how does that look from a regulatory point of view, John? Am I throwing you in the deep end there? Or?
No, not at all. I totally agree with what Sid Green has mentioned. I think the ultimate goal should be to reduce CO2 emissions. And in a sense, it's kind of a moonshot idea, right? It's like John F. Kennedy said, well, we want to put a man in space and we want to land someone on the moon. I think reducing CO2 emissions, if we had the governmental leadership at the very top to say that's the goal, I think everyone would rally around that. And the other thing I would mention is that I saw a recent article about Steve Jobs and his creation of Apple and the Macintosh computer. His idea was to put the power in the hands of a user and say, you can create what you want, but here is a small tool to do that with. I think maybe we ought to start really looking at ways to put data in the hands of a consumer so that they're knowledgeable enough to know that this particular action I take, whether it's, paying for renewable resources through my utility bill or whatever, what effect is that having on carbon reduction? If we could take an index number and give feedback to the consumer directly and say, this is what your action is doing to reduce carbon, and put the power in the hands of individuals. You aggregate that up to all the people in the United States, and maybe you have some real value in reducing carbon emissions over the course of time. But those are just some ideas. I don't know what it's going to take to get there. I've never desired to be a politician, but at some point, it's got to be political will to say, we're going to focus on the end goal, what the true goal is, and make attempts to get there.
But putting the right information in the hands of consumers, that's a pretty good message, isn't it? That's leadership.
Yes.
That's great. Bill, with anything to add to this?
I don't really know politics very well. I don't really understand it. I don't like it, but I can't say that I understand things. I don't know if putting the information in the hands of the consumer will work or not. Let me give you one example. The national retail average cost for a kilowatt hour of electricity is 17 cents. In Utah, it's 12. In California, it's 31. Largely because California has taken steps by their leadership in mandating renewable resources, shutting down some power plants ahead of their useful life and going forward. I don't know if the average consumer in California understands they're paying 2.5 times what we are. Or there are some states in the South, like Alabama, that also have largely existing coal and fossil fuel resources. Alabama is very low, lower than Utah. One of the panelists earlier said that, and I think Sid was among them, who said that we cannot just dismiss oil and gas and coal because that would shut down civilization. And I think that's obviously true. But where the public is on this, I really don't know. There's such a division between the two political parties, with Trump saying recently that climate change is a fiction, and attacking Biden because of his emphasis on electrification of the transportation system. And of course, Biden takes the opposite approach. It's a tough one.
It's a tough one. It's reflected worldwide too.
Yeah.
Right? This is, it's not just about America. It's about the world, and the same division actually occurs in the world as well. Okay, we're coming towards the end of our time now. It's a couple of things I want to get in. One, Sid Green has actually written down some introductory comments here, and do you want to? This is something that's available to anybody that wants to read a longer version. Yeah.
Yes, absolutely.
Yeah.
I'll leave here. I have some copies, and so anyone will have. Can I comment on the last bullet, how EGI?
Yeah. Well, that's the question I was going to ask, but you do that. Yes, please.
Well, we're out of time.
I was going to use the last few minutes for that.
Maybe EGI could do some things that industry can't do very well. I don't think ConocoPhillips or Chevron or EGI are going to stand up and tell the emperor he has no clothes. But I think maybe EGI could do that to some extent to help them to look at this complete analysis. You hear, even though I suggested I raised the question of the complete analysis formation, it's not being picked up. You guys didn't pick it up. Nobody did. They just talk around it. And why are we so afraid to look into this to understand that this electric vehicles, is it really going to lower carbon dioxide emissions?
Yeah, but is that EGI's job to do that?
Well, their job might be to help do things that it's hard for industry to do.
Yeah.
I mean, if Chevron or any of your companies get up there and start raising that question, I can't imagine you'd want to do that. Your shareholders and groups would kill you for that. Just raising the question that isn't good. And so that's why I say, how could EGI be relevant to that?
Great, and so don't forget that Sid's got an information sheet here. I want to, on this, as a final question, just this thing about how can EGI make itself relevant. I'm going to throw it over to Sid Jones now, and because I know that Chevron, especially, has involved itself in some of EGI's other activities. You've sent a bunch of people to Forge and so on. So and any comments on how EGI can make itself relevant?
Yeah, absolutely. And thank you for offering me the platform for that. Coming back to my earlier statement, where as we were looking at this energy transition, we were also looking at a human transition where we have to transfer skills from one generation to the next, and then broaden those skills into other areas of investigation with all of these alternative energy forms. I will make the strong argument that where in the past, the majors were large enough to have kind of a mentor-mentee relationship and an internal education system inside Exxon, inside Chevron, and inside Shell and BP that passed that knowledge from one generation to the next in a fairly structured manner. Today, we don't have that anymore. We have, we Chevron, I'll say Chevron, yes, and the rest as well. We have deconstructed that over the past 15 years as the I'm not going to blame the boomers, but the boomer generation has aged and is starting to age out and retire. They have not left behind a strong system for transferring their knowledge base to the next generation. So what I'm going to argue is that it's exactly organizations like this that are large enough that have inputs from multiple sources where they're receiving funding from a lot of different people who are going to have to carry some of that torch forward in being able to transfer those skills from one generation to the next. And so I, very much, I see our involvement here. We are relearning some skills that Chevron actually let go. We were actually, 15 years ago, we were one of the largest independent geothermal energy producers. We have none today.
Well, that's great. We're very grateful
That's
for
it.
your interest in cooperation as well. Christy, I think you had something you wanted to say to finish up, and we'll make that the last thing. Or was I wrong?
No, I do have a call to action for EGI. As I mentioned, it's not just about carbon, it's about water resources, it's about land use, it's about community engagement and the social responsibility that we all hold. And I think focusing your research on helping us do our business better is just as important and relevant as it has always been. So I think geothermal, CCS, hydrogen, and I'm really excited for this afternoon session, focused on more sustainable grids, more sustainable energy usage activities are incredibly relevant, as well as how do we engage and get support in doing what we do better, and to make sure we're behaving as responsibly as we can with new technologies, new research, new focus areas. So I really appreciate this conference, and I really appreciate the things I've learned about, and will continue to learn about in the conference. As mentioned, a lot of those, we're not going to do a lot of those things in-house, and we're not necessarily developing those skills of the future generations in-house. So those are also incredibly valuable. Continue being a partner, continue engaging with the oil and gas industry in the future would be my biggest ask.
That's a very positive message to finish on. So thank you very much. I want to thank the panel for a really, really interesting and incisive discussion. I think we should give them a big hand, don't you? Now I want to pass you over to Al, who's got a special award announcement to make.
No, Al, you can go on back, but John, why don't you just stay there for a minute? Particularly difficult for you. And when I saw some diving folks if they go outside, you might want to grab them so that they don't miss the. I'll capture them. Sit down for a minute, John. It's okay. Yeah. It's gonna be a long one. Yeah. You know, what was very interesting this last panel was on leadership and change and transition and the right thing to do. So it just seems that this award is just perfectly timed to take advantage of that. So it's my pleasure and my honor to present the 2023 EGI Service Award to the Director of the Utah Division of Oil, Gas, and Mining, Mr. John Baza. John's bio is in the program book, but I'd like to go a little bit beyond that. John and I started at Amoco as rookie engineers at the same time, and this was during one of the early 1980s oil booms. And he was in Casper and I was in Evanston, Wyoming. And we'd run into each other at different training courses in Tulsa and all these garden spots that we had in the oil and gas business back then. And we were the old guys because we were over 25. And one of the things we'd laugh about when we got together, and this was a few decades ago, was how green these young engineers were that were coming in. They were 22, 23-year-olds. And clearly all of them had more money than brains, except for John and I, because we had a little bit of work experience and we both had master's degrees at that point in time. So we were all over this. But when we started, West Texas Intermediate was $30. It had tripled from the year before. So it was a pretty amazing time to be entering the business. Just about everybody had more money than brains at that point, including the corporations. But we were sure it was going to $100, but it had to go through $8 first, and then back to $100 about 22 years later. And then we managed through numerous busts and booms to here be 4 decades later. We were lamenting this morning that we don't do much engineering anymore, either one of us, but you know, it's good that we do get to touch it a little bit now and then. So during this 4 decades, he's faced increasingly awesome responsibilities. And he's usually ended up in charge of a lot of things. And he's used his Stanford education, his professional engineering certification, his industry experience from Phillips and Amoco and Flying J to serve the citizens of Utah. And he said he's Utah centric, but he has served this nation in a lot of ways. Not just in petroleum, but he's dealt with mining and geothermal. He's helped us through several
disasters such as the Crandall Canyon coal mine crisis, and then decades of regulatory and legislative actions. At the Division of Oil, Gas, and Mining, he has instituted a lot of changes, as we were talking just about transition here, but a lot of technological changes such as using drones for GIS. He's updated their e-permitting system, and he's rebuilt their data management system. And I just came from California, and California thinks they're a technological lead, but the Division of Oil, Gas, and Geothermal Resources in California copied his system and then spent $60 million more so that anybody from any country could file a permit in California in any language. So they spent a lot of money just to make it accessible to everybody. He's also been a leader on the Interstate Oil and Gas Compact Commission, the Interstate Mining Compact Commission, and he currently serves on the board of the Groundwater Protection Council. At the IOGCC, his leadership was recognized because he received the Marland Award there. And I've watched him in action at the IOGC and groundwater protection, and he served on the National Petroleum Council for Secretary Perry. He's highly respected, and consequently, Utah's pretty well regarded. And our nation is very well served by John Baza. So John, if you could please join me up here. Sadly, John is retiring this year. We know we're going to cross paths in all these garden spots around that the industry has, but I'd really like to have you please join me in congratulating John Baza on receiving our 2023 Service Award. Yeah, thank you. Thank you, John. Caroline, did you get a good picture? Okay, let's see if we can get a better picture. Yeah, I'll let Jenny get down here too. Okay, one more for Jenny. Yeah. Okay, go ahead, John.
Well, Al, I'm really glad you were the one who got to say all those words, because as you said, I mean, we got to know each other fairly well back in the old Amoco days, and those were pleasant experiences. I am deeply honored today for this award. I appreciate the fact that, you know, when one is ending their career, sometimes they get recognized for a lot of things that they didn't mean to do. But Rob Simmons said yesterday that experience is a series of learning from your mistakes. And heaven knows I've made a bunch of mistakes in my career. But I think that there's been some good things that come out of that. And I would say most of all, that this award, if we could break it up into chunks, each one of you who I've associated with over the years could have a piece of this award, because you're the reason I am what I am. I look at Al, I look at Millen, I look at John McLennan, Sid Green, all of the people who I've associated with over the years, and you've contributed to whatever my career has meant. So I don't want to accept this award just for myself. I want to accept it for every single person that I've collaborated with, associated with, that I've partnered with over the years, because you are the people that have made me what I am. Many years ago at Stanford University, our professor, Henry Ramey, was looking at this small group of petroleum engineers saying, look around the room. The people you see today, you will encounter numerous times over the course of your career. And he was right, because this is a small circle of associates. And I look at EGI and the things you're doing, and even the depth and breadth of information that's been presented over the last couple of days. These are the people that are going to solve the problems of the future. And the youth that's coming into the industry these days, and I see them and their passion and their commitment and their desire to do the right thing. I have wonderful aspirations for the future of energy and minerals and where we're going in the world today. So EGI, congratulations on helping me receive this award. So thank you very much.
Okay, lunch is next door. We'll reconvene at 1 p.m. Thank you.